So welcome to the next German Mathematik-Olympiade from 2023. So today we are going to solve the problem number 3 for 8th class. Here we read the text and try to identify important parts from the task. So this, when you solve the problem, try to focus on everything what's important. God bless this. Actually, it's specified exactly here. So what we have, we need to fill any table from 1 till n. In our case, we have 2 examples, and they have some rules. So the rule number 1, okay, too much. The rule number 1, it means we want to have that on each line here or here, we limited 3 crosses. So 3 here. It could be like this or like this, right? So in total, or it could be like here. So in total, we have 3 per line or 3 per row. That's good. That's what we know. The second line told us that this one, it says that there is no cross here. So this one actually it's forbidden. It's forbidden. So don't use this line, this cross, the same number, the same row and column, there is no cross. And third rule says that there is a cross. When you have a cross, let's remove this one. When you have cross here, 4 and 1, it means there is exactly opposite here, the cross. So if there is, we have put cross here, then it should be goes here. And yeah, that's all. So what can we see here? When you start doing, we just follow the first process. We know there is, the first line says it should be only 3 crosses. So we can already calculate how many crosses do we have. So it means that the number of columns and numbers should be more or less the same. And because we have 1, 2, 3, 4, 6 rows, or we can use columns, doesn't matter, multiply 3 crosses, and it gives us, in total we should put 18 crosses around this table. So we should remember this number. For this case, we have 5 rows, still same, multiply 3 crosses per row, and we have 15 crosses in total. Okay. Next line. It says that we couldn't put something, so we go and mark some places that for sure we don't have any crosses. So it will be, you should visualize and try to ask for paper or try to draw it as much as possible for different scenarios. So try to put everything here. And third line says that it's actually symmetric. So it means if I put here, I have exactly 1 here, right? So the number of total crosses, it will be the same amount. We can identify that this area number, of course, it will be exactly this. So if you see, everything's symmetric against this line. So what we learned from this stuff, it means that the number of crosses to make it work should be even, right? So it should be divided by 2. Why? Because we couldn't put like here 3 and here 4. Give me an example. So the case like this couldn't be exist because we need number here, right? So that's why it should be even, always even. So with this information, we know that the second solution, when we have 15 crosses, right? So it's not even. That doesn't work. So this solution could not work for our rule. That's, we can explain that we know that it should be even because it's symmetric against the line. So whatever we try to put crosses, we wouldn't make here. So here we still have some possibility to finish, or maybe it's not. So not important like here, but we already know the solution here. It's put no, this fails. Okay, so let's review the first one. We know that we need to put 18 crosses. So per one side we need to put 9 crosses. And here it will be tricky because what in the beginning you can put it in, I call this brute force solution or dynamic programming solution. When you try to fill, let's start, just try to fill anything. So you don't need to create any example, all examples, all solutions. It could support multiple solutions, but we need just fill the first one. So we don't need to fill this one. We don't need to even to try because we proved it wouldn't work. But here we still need it. So we still keep the lines where we couldn't put crosses. It will show you. And try to put some like just here we want to distribute 9 crosses. So we say, okay, we put 3 here. So we couldn't put any more. And what it means, we also put here other one. And here, yeah, so we already marked this one. It's not available for put. We still have 2 on the second line. We have 2 on second column. We have still 2 placed. So we put 2 crosses, and we mark our lines. Then we do the same here, and actually you see like the 4 multiplied 3, it's 12. It's just fill everything, it will be enough. Okay. What we have now placed, we can mark that it's not possible to put here, not possible here, here. So, and we have only one place for cross. So this, you see that this line doesn't have enough crosses or even etc. So this one, it doesn't work. We need to distribute our crosses a bit more, like more like not put everything in the beginning in one row or column. So what we need to do is, let's add some step. So we have some pattern, and let's add example 1 space here, 1 space here. So 1 2, and we have 1 2. Same approach here, we put it here like 1 step 1. So we have 1 3, 1 3, and 6 3. It should be here, right? And from this we mark, you mark. Already you couldn't put anything here. We couldn't put here anything. I missed something, but okay. 1 2 3 4 5 6 7, and let's put here some symmetric solution, right? So 1 2 3 4 5 6 7 8 9, right? So we put it here, here, here. Okay, I think I put extra here. It's not correct. So we're gonna put here 1 2 1 2 3. So no here. Yeah. So this is one example. We just moved a bit, shift next column with crosses a bit, so it's put like here, and instead of go here, we put here. It gives us a bit more distribution around to not occupy the first square and distribute squares around all field. And 1 2 3 4 5 6 7 8 9, it's our solution. So we build it. I tried to fill, for example, we could not fill square with 5, but it totally worked with 6. What about 8 columns? 8 multiply 8. This will be, you should prove it if it works or not. Try to test it at home. Yeah, that's all.